sequencing decide yes or no, step by step, just like humans. That's exactly where a decision tree comes. Decision tree is a supervised learning algorithm used for classification and also regression. It splits data into smaller subsets based on the conditions. Like decision tree consists of root node, that is a starting point, internal nodes, that is decision features, branches, outcomes of decisions, and also the leaf nodes, which are at the end. So final output. And decision tree works like a series of if else statements. For example, if age is above 18, then it is yes, else it is no. So if else statements, like that it will be working. And how it builds a tree step by step, it will start with a full data set, it will find the best feature from that particular thing, and it splits the data into subsets. Then it will be repeatedly doing the recursively doing the steps, right? So here we'll be doing entropy. First, entropy is the measure of impurity. As you can see, entropy is a measure of impurity. We'll be finding the entropy for binary classification. For example, yes or no, or the both things, that is binary classification. We wanted to label whether it is yes or no. We'll be using the entropy formula in this particular way, right? And the key idea behind this is, if high entropy, then it is mixed data, and which is bad one. Okay, we can't get a clarity upon mixed data. When it is low entropy, then that is pure data, that is good. So we can proceed with it. Entropy is 0, then it is perfect classification, right? Then comes the information gain. As you can see here, information gain is which feature should be split on, so that we will get a proper split. So we will be using information gain. Information gain is entropy of parent minus weighted entropy of, again, into entropy of the children. Higher information gain gives you the better split, and goal is to maximize the information gain so that we'll get the better one. As you can see, firstly we will be finding the entropy of the parent, then we'll be calculating the entropy for the children. Then that means children in the sense the subsets that are there, the features that are there. Okay, we'll be finding entropy for the features, then we'll be calculating the entropy of the children, right? Weighted entropy of the children. Okay, so that we can able to classify the things. And we'll be finding the information gain. So after finding information gain for all the features, we'll be we'll be filtering out which is the highest information gain. Then until there we'll be finding information gain unless we get the highest one. Okay, so another way to measure impurity will be the Gini index or Gini impurity. That is this formula: 1 minus p yes square, probability of yes square, plus probability of no square. Like this also we can find instead of that ig. So low Gini means pure node, and high Gini means mixed node, which is bad again. So decision tree uses a greedy algorithm at every step. Choose the best feature, highest information gain, no backtracking. So overfitting problem is there. So for that, decision trees can easily overfit the data. Works well on training. We can look at the disadvantages of the decision trees, that is overfitting. Got it? So it is a problem that is there in the decision trees. They can easily overfit the data. Works well on training but performs poorly on the testing data. That is what the problem is. And we have come with pruning as a solution. To fix overfitting, we use pruning. Pruning has types: pre-pruning and post-pruning. Pre-pruning means stop early. That means when you have seen the maximum depth, you can stop. Post-pruning means build the full tree and then cut, like that. Okay, in this also there are like advantages: easy to understand, no heavy data presentation. That means there are advantages also there in this decision tree. You can easily understand the decision tree. As you can just see the tree, you will be able to classify what are the things are. And no heavy data preparation will be there, and fast interference will be there, logarithmic time, right? Yes. And you have already seen the disadvantages: overfitting and error in the imbalance, so can become complex and sensitive to imbalance of data.